So the second half of our 2.5 lesson is going to be about how we can solve a rational equation. And we're going to use that LCM technique that we used back in the linear equations chapter, way back at the beginning of class, where we wanted to get rid of the denominator. So we multiply through by a least common multiple. So let's talk about, and this one is the first one. When I look at this rational equation, and it's a rational equation because there's an x somewhere in one of the denominators, can't really solve it the way it looks algebraically. So what we're going to do is we're going to look at all the denominators, which the only denominator that is of any interest is the x minus 4, and multiply through the entire equation by whatever the least common multiple of that denominator is. So for us, x minus 4 times 1, the least common multiple of that is just x minus 4. So that's what they did here, is they distributed the x minus 4 into each term. And you're going to recognize that on this middle term here, the x minus 4s are going to cross cancel each other, and you're going to end up with a, way less exciting algebra equation. So it is, let's see if it continues on. Well, let's go ahead and finish solving this. So the distribution here produces a quadratic, x squared minus 4x, and then it's just a minus 8 for the next term, and then 11x minus 44. So we still are going to have a quadratic equation, and we're going to have to solve. Let's bring everything to the that side, left side. Let's see, negative 15x, and then adding 44 over would be plus 36. Yes. And then great news, I think this factors. So how about x minus 12 times x minus 3 would yep, that would work. So you get two solutions, x equals 12 and x equals 3. The only thing you have to watch out for is when you go back to your original denominators, you got to think about what an excluded value would be for this equation. If x was 4, that would produce a divide by 0 situation, and we can't have that because it would, not work. So notice neither of my solutions produced x equals 4, so we're going to accept both of them. You could full out check them, and if this was a summative and you find yourself with extra time, yeah, check your answers, man. This one's all worked out, but let's recognize here that when I looked at our denominators, this one's kind of unusual because we have monomial denominators as well that are kind of in pieces. So I can clearly see that an x minus 2 has to be included in my LCM list, but then I have a 3, and then later on I have a 6. Well, it's like 18 is a common multiple of 3 and 6, but 6 is the least common multiple for 3 and 6. And you want to kind of use the least number possible because remember, our algebra is going to get kind of crazy. So if you're really in a jam and you can't figure out what you think is the least common multiple, just come up with any old common multiple. It might give you really hard math though, so I'm just warning you. But they already went through all this work. Isn't that nice for us? So they multiplied through. And then what I like to do as an example is down here, I've written like all the multiplication problems like side by side. And I want you to recognize who's going to cancel here. So like the x minus 2, they're going to cancel. And then the 3 and the 6 will like partially cross cancel. The 6 is going to become a 2. So you still have to multiply the 2 times the x plus 1. That's where they're getting this from. And then on this next term, the 6 will cancel, but you still have to multiply the 5x times the x minus 2. So that's where this term's coming from. And then on this last guy, the x minus 2's will cancel, but you still have to multiply 6 times 1. And that's where that 6 came from. So that's a nice little example of where everything came from. They distributed, collected like terms. It was a quadratic. They factored. And then they went through and they looked at the original denominators and they said, uh-oh, this guy right here, that's a problem. It's an excluded value. So we're going to say it's an extraneous solution, but 2/5 is going to work for our solution. Usually the next thing kids ask me is, well, what happens if they both are extraneous? And then that means you have no solution. So, and then another question would be, well, what happens if neither are extraneous? Then you have a couple solutions and that happens too. So this one, I'd do a little manipulation before I did any LCM work. Let's subtract that 8 over and make it 2. So we have 15 over m minus m. You can say over 1 if you want. And then equals 2 over 1. So coming up with the least common multiple, this one is easy peasy lemon squeezy, it's just m. So you're multiplying an m to each term. This one's pretty basic, so I don't think I'll write it out the long way, but notice in this first fraction, the m's would cross cancel, leaving you with 15. This next fraction, nothing cross cancels, so it's m times m, which will be m squared. And then the last fraction, nothing cross cancels, so you have 2m. So once again, we have a quadratic. I'm going to bring everything to the right this time because that'll make the quadratic term positive. There we go. Oh, it even factors. Look at that. X plus 5 times x minus 3, which give me two solutions. X equals -5 and x equals 3. And if I go back to my original denominator, the only thing in the world that would be a problem here would be if x equals 0, which is neither of my answers. So I'm going to go ahead and accept both answers. They're both good. All right, number 2. These denominators, the pieces are b minus 3, and then there's b, which is a totally different number, and then another b minus 3. So when I look at my common multiple list, I need not only a b, but I also need a b minus 3. Those are two completely different numbers, so make sure they're both listed in your common multiple list. And when you distribute, if you have a hard time seeing like what's going to cancel, you could write it out the long way like we did on that first example where like we had the red one followed by the rest of the equation. So basically you would draw like an expanded version of this equation out with a red b times b minus 3 in front of each term. Takes a lot of writing. Go ahead and pause the video and do that step if you need to. I'm going to skip that step though. So in this first equation, first fraction in the equation, the b minus 3's will cross cancel, but you're still going to have a 4 times that b that did not cross cancel, because remember it's both terms here. And then there's a plus sign, and then in the next fraction the b's would cancel, but we still have the 3 times the b minus 3. And then in the last fraction, the b minus 3's will cancel. We still have the -2b times this extra b. So can I just write that as -2b squared? All right, little distribution. We have 4b plus, let's see, distribute this. So 3b minus 9 equals -2b squared. Quadratic, big shocker, I know. I'm going to add the 2b squared over, combine these b's together. And then I'm going to like hope that this factors. I think it does. So that's the good news. Oh yeah, this is going to factor. So 2b and b. And then if we say plus 9 and minus 1, that'll be 9 minus 2 is 7. Yep. So solving this factor, you get -9/2. And then solving this factor, you get 1. And then I think about what would be a problem for this problem. And 0 would be a problem, and 3 would be a problem. Good news is neither one of those are my solutions. So they're both going to work. Sorry if you my phone going off. I don't know what's happening. All right. So number 3 is, it could be really difficult if we're not sneaky. So I need to have as many common things in my denominator as possible. So you have to think about y squared minus 4 and what that means if you kind of break it apart into its multiple numbers. In other words, factor it. Isn't that just y minus 2 times y plus 2? And then the other thing we have to be kind of sneaky about is right here. This almost looks like y minus 2, like it's just backwards. But in math, if things are backwards like this, what you have to do is you have to factor out a negative. And then when you factor a negative, that creates a -2, and this becomes a plus y. So if you think about that, what we really have, first fraction is what it was. But this negative and this negative can combine to a plus sign. And then in the denominator, instead of -2 plus y, that's the same thing as y minus 2. So if you want the opposite factor, you have to take out a negative sign from it. But that negative you took out has to float either to, the plus becomes a minus or the minus becomes a plus because of the double negative rule in that case. That was a very sneaky little trick. So I generally won't mess with you like that. However, on the SAT and the ACT tests, they like to do crazy things like that once in a while. All right, so this is awesome news because when I look at my denominators, I see y plus 2, y minus 2, and then I see a repetition of those same terms. So when someone asks me, well, what's your common multiple? I'm going to say you need a y plus 2 and you need a y minus 2. And you want to leave it in factored form like that. So I'm going to take a little shortcut when it comes to what's left through my distribution. This first term, the y plus 2's will cancel, but you still have a 2 times a y minus 2. Right? The plus 2's are gone. And then the second fraction, the y minus 2's are going to cross cancel, which means you still have a y times a y plus 2. And then the last fraction is amazing because they both cancel. So you just have a y squared plus 4. kind of looking ahead to my work I already did. Hey, there's some excellent news. It looks like a quadratic at first, but I think it's not going to be a quadratic in a second. Let's see why. We have y squared plus 2y. It's going to work out great. The y squared terms are going to cancel each other out. Whew, look at that. All right, so collecting these y's, I have 4y, and then if I go ahead and add this 4 over to here, I'm going to have 4y equals 8. I get y equals 2. And then after all that work, I'm so excited to get y equals 2, and then I'm going to probably circle it in and just move on, but really shouldn't, because look up here, guys. A couple of places, right here or in this denominator that changes, if you plug in a 2 for the y, it's going to give you a divide by 0. So actually this is an extraneous solution. So there is no solution to this problem, which in itself is a solution. So don't feel like we wasted our time. The fact that there's no solution and I can prove it algebraically is a skill. All right, number 4. Well, that one's not too bad. The only thing that we run into on number 4 is sometimes kids think x and x plus 3 are like terms, like partial terms of each other. They are not. X is one number, and then x plus 3 is a totally different number. So when I ask you for your LCM, you need both an x and an x plus 3 in order to knock out all your denominators. So this first fraction, the x's would cancel, cross cancel, but you'd still have a 60 times the x plus 3. And then your next fraction, the x plus 3's would cross cancel, but you still have a negative 60 times x. And the last fraction, nothing cross cancels besides the 1s, so you still have an x times an x plus 3. I don't like to jump the gun and distribute as I'm rewriting this step because this is really a step where kids mess up, so slow your roll a little bit, child. All right, distribute the 60. Usually when I start yelling at you guys to slow down, this is where I make a mistake, ironically. So let's see. We have a quadratic. Whoa. All right. Good news though. 60 and minus 60x are going to cancel. So I'm just going to bring everything over to the right side. X squared plus 3x minus 180. Oh boy. So looks like I already factored this at some point in the past. Good news, because it's actually not too bad. 12 times 15 is 180. Spoiler alert. So x plus 15 times x minus 12 would work for this factorization, which means I get two solutions again. X equals negative 15 and x equals 12. And if I look at my denominators, 0 is an excluded value and negative 3 is an excluded value, neither of which I got. So what are my solutions? They are both negative 15 or 12 is also a solution. Oh, 5. That's not too bad. Again, we have to be careful that we include everybody in my LCM count. So like I see an x, I see a 4, and I see an x plus 3, and those are all different numbers. So a 4 and an x plus 3. Okay, I think I kind of spoke too soon about this not being bad. It's pretty bad. Let's distribute this. Oh, it's gonna be... Oh, all right, sorry. This first fraction, the x will cancel, but you still have the x plus 3 and the other x plus 3 and the 4. So please watch out. This is actually going to be a two-step distribution problem right there. This next fraction, the x plus 3's will cancel, but you still have a 7x times that 4x. And then on this last fraction, all that's going to cancel is the 4. So you still have a 7, no, 23. Still have a 23 times an x plus 3. Ugh. All right, this is the one I'm worried about. You need to distribute this in parts. So x squared plus x plus 3 times x plus 3 is x squared plus 6x plus 9. But then that has to be distributed by a 4. You don't want to distribute the 4 to both parenthesis sets, because if you do that, you're actually distributing a 16, because it's 4 times 4. So now I can distribute the 4 and write down 4x squared plus 24x plus 36. And then 7x times 4x is 28x squared. And then 23x times x is 23x squared plus 69x. So clearly we have a quadratic. It looks like if I bring everything to the left side, that'll keep my quadratic term positive at least. So let's see, oh, that 9x squared. And then if I subtract the 69x over here, it gives me negative 45x, and then there's still a plus 36. Now, I noticed that everything here has a common 9, so I'm going to get rid of that. So x squared minus 5x plus 4. Oh, that's not bad. We can factor that. Minus 4 and minus 1 will work. So my solutions are x equals 4 and x equals 1. And when I look back to my excluded value possibilities, 0 and negative 3, and this one doesn't have an excluded value, like nothing will make that divide by 0. So negative 3 and 0 are my only problems I would run into, and I didn't get either of those. So turns out those are both good solutions. Well, solving these algebraically is not awesome, and if I don't have to, like if I'm in a standardized test and they don't tell me how to solve it and I have access to a graphing calculator, that is the quickest method because it also won't show you the extraneous solutions. I'm going to require you to solve them algebraically. In fact, I might be sneaky and ask you, like, solve it algebraically and tell me which is the extraneous solution. So that way I will know if you cheated and used your calculator. So this one, I'm going to just show you what it looks like to use your calculator. It's not bad, and you're going to be like, oh, well, why can't I always use it? We talked about this. Half the SAT test is no calculator. Plus, your calc teachers can expect you to be able to do all this technique on some much harder problems in calculus. So surface area for a box that looks like this, you're going to have, well, first of all, they told you the surface area is this. So that's like the end of the equation. But it says the sides are x, and then they must tell me something. Okay. Oh, well, they have surface area, so I think we're good. Okay. So, oh no, that's not the surface area. Bruce, read, girl. There's volume right in front of it. Blah, blah. The volume, and they're going to want me to find the surface area. Okay, that makes more sense. We're going to do some substitution in a second. So all the sides of this is like a square base. They're going to call it x. And then the height, I have no idea how long the height is, so I'm just going to call it h. So all these guys are h's. So I know to find the volume of a box, it's length times width times height. So according to this equation, the volume is 625. And then the length and width are x times x, and then the height is some mystery h. So what if I wrote it like this? The question is, what does it say? So they want me to write the setup for the surface area. This will be a hoot. All right, so the problem is this h. I don't have any numbers for h, so if I can just quickly solve for h, that'd be really easy, actually. We could just divide by x squared. So I'm going to represent the height of this box as 625 divided by x squared. And that's going to come in handy right here, because the surface area of the box would be 2 of these square pieces, which are 2x squareds, because the area is x times x. And then it's going to be 1, 2, 3, 4 of these rectangular pieces that are x times h. But do you remember how h is not really h anymore? H is now this dude. Okay, which I can actually pretty that up a little bit, couldn't I? Now, if I'm about to use my calculator, I don't know if I care, but let's clean it up anyways. This fraction right here, one of the x's would cancel. So I think I cheated. It's 2500. So this becomes 2x squared plus 2500 over just a singular x, because one of the x's cancel. So this is a good representation for the surface area of the box. Write the function as quotient 2 function. Boom, there you go. And then it says to find the length of the base when the surface area is 512.5. So I could totally set up an equation. I sure could, but I'm not going to. It actually wouldn't be too bad to solve algebraically. You just multiply everything by an x, but you know what? I think I take that back because you're going to get a cubic. Ooh, I don't want to do that. Okay, we're going to use our calculator. So what we're going to do is we're going to type one of these into y1 and the other side of the equation into y2. And I'm going to go ahead and pause this video, and you're going to type those in, and you're going to graph them. You're going to try to find where they intersect. So through the magic of the internet, I've already done this. These functions actually intersect in 2 places once you find the appropriate window. 5.54 for one of the x values. I don't know what the y value is. I didn't write it down. And then 12.5 is the other x value for the other ordered pair where they intersect. So sometimes one of these solutions is extraneous just based on the significance of the problem. So like if it ends up giving you a negative surface area, like that doesn't make any sense. But I think both of these actually work, which is kind of annoying. So if this is the correct solution, that means my box is, the x is going to represent the box, right? And they want like times width times height. So the box would be 5.54, what's the label on here, inches, by another 5.54 inches by, and then if I plugged in, plugged it in right there, I would get, I wrote it down, what did I get? 20.4. So that's one option. Option 1. And then another option for this box would be if the x equals 12.5. So then the box would be 12.5 by 12.5. And then if I go plug in 12.5 right here, I got 4. So basically it's a matter of, do you want like a really tall box or you want a really squat box? And both apparently work. That sounds like a manufacturing problem from there on, so they can decide on their own. All right, so that's the idea. We can solve them algebraically. It's not terrible, and you will be required to do that. You can check on your calculator, and when given the opportunity to use technology because it's an application question, yeah, we're going to be using technology for sure. All right.